That gives me the slope of the line segment, but does that give me distance? That does not give me distance, so it's not that one. It's an offshoot of the Pythagorean theorem, yes, because I could make this into a right triangle, right? And then I could square this, and I could square that, and that would give me the distance squared, right? Okay. So how am I going to find that x and that y? It's the square root of something. Bingo. Right? It's the square root of the difference of the x's squared plus the difference of the y's squared. Okay? That's always going to be the distance formula. No matter where your points are. That works. Sorry, dear. Is that better? All you got to do is ask. Exactly. Exactly. Picking up right where we left off. 8 more weeks. Just keep singing somewhere on the beach. I know. Okay? Is that connecting any synapses and neurons and whatever's going on up in the old wet noodle? What? Into math terms? You remember it? Alright, so find the distance between those 2 points. Well, my distance is equal to, I first have to subtract the x's. Does it matter which order I go in? What does it matter? Do I start with this one and then go to -3, 2? Or could I start with -3, 2 and then go to the other one? Doesn't matter. Okay, so it doesn't matter which one I start with. What matters? The order of them matters. So if I'm starting here with -5 minus -3, then I had better, on this next one, start with +1. -5 minus -3. Oh, shouldn't be outside. Yep. Good eye. So you're saying I should have wrote it like that? Yeah. Good call. Good call. Good eyes. What we got? -5 minus -3? -2. That's still squared. 1 minus 2. -1. That's still squared. -2 squared. 4. -1 squared. 1. So that gives me a distance here of square root of 5. Now, I will tell you this, that it is nice to leave it in reduced radical form. Why? It's an E word. It's exact. It's exact. Okay? Alright? So the distance between those 2 points is the square root of 5 units long. Okay? Questions on that? We'll get into that more in a minute. Let's hit up midpoint. Okay? Midpoint, also you have seen. Okay? Now, it looks But what the midpoint is, it is the point that is in the middle of two other points. It bisects the segment. Okay? It cuts the segment into two. And what you do is you take the x values, add them together, divide by 2. Take the y values, add them together, divide by 2. Okay? Distance is a number. Okay? The distance is a number. The midpoint is a point. So we need to write it as a point. Okay? So we average the x's, we average the y's, and we write it as an ordered pair. Okay? Find the midpoint of the segment joining -2, 3 and 4, -2. Well, I take the x values, -2 and 4, I add them, and I divide by 2. I take the y values, 3 and -2. I add them and divide by 2. -2 plus 4 is 2 divided by 2 is 1. 3 plus -2 is 1 divided by 2 is 1/2. So the midpoint of those 2 points is 1, 1/2. Okay. Distances, I want it in reduced radical form. Midpoints, I want in fraction form. Okay. Unless the problem is given to you in terms of a decimal. You know what I mean? Because I think there's one on the homework tonight where it's like the point is 4.7, 5.2, if memory serves me right. But so then in that case you could give me a decimal. I had to think of the word there. Kinda. Alright?
Hey, geometry.
Types of triangles, yay! Trees.
What?
Oh my god.
Why?
Where are you getting trees from this?
Geometry.
Wow.
That's hard.
Yeah, it is.
Yeah, especially when you don't do your homework. Scalene triangle. What the heck is a scalene triangle?
It's equal sides, not sides, so it's a right triangle.
Your what hurts?
It's a right triangle.
No, a scalene triangle is not a right triangle.
It's a triangle where none of the sides are the same.
0 sides are equal.
Yo, I'm trying.
Dude, you were honestly thinking of isosceles.
You used to be isosceles.
What about isosceles?
Two of the sides are equal.
2 sides are equal.
Jason? Yeah.
Don't worry, I got the last one for sure.
What do you got?
All three
All 3 are
are equal.
equal.
I would have said rectangle.
Him? The reason I remind you of back when you were a tree is because some of your homework tonight is going to be classify the triangle. It's a great way to bring everything in because what I can do is I can make one problem be 3 distance problems. Because if you have to find if you got to classify a triangle, you've got to find the 3 side lengths. So it's 3 distance formulas. Okay? Classic Lindsmeyer. Huh? Alright? So it says classify the triangle with vertices of that. What I would like you to do is I would like you to find me the 3 distances there, and then we'll determine what kind of a triangle it is. Okay? So distance me all 3 of them. Spot check AB. So if I'm doing segment AB, that's going to be 2 minus negative 3 quantity squared plus 1 minus 3 quantity squared. Take the square root of that. So 2 minus negative 3, that's 5. 1 minus 3 is negative 2. So that's going to be the square root of 29. Yes? Now, in this particular case, even if it was like the square root of 24, let's say, would I have to simplify it? No, because I just need them to be equal, right? I'm looking for equality, right? If it was asking me what the length is, then I would have to simplify that radical, right? Square root of 29 can't be simplified, so we're good there, right? AC. So that's going to be, I'll go in a different color. That's a horse of a different color. Name that movie. Nobody? Horse of a different color? That's a horse of a different color? That's Wizard of Oz right there. So what's that? That's 4. What's that? That's 3.
Is homework on the slides?
Will be. I get 5 for AC. Yes? Okay. B, C. So that was, sure, we'll go purple. Okay, so that's negative 3 minus negative 2 and 3 minus negative 2. That's 1, right? Actually, it's negative 1, but who's counting? And that's 5. So that gives me the square root of 26. Agreed? Yes? So, are any of them equal? No. Okay, none of them are equal. If you wanted to leave AC here as the square root of 25, you could there, because we're just looking at their lengths. And all of their lengths are different, so what kind of a triangle is this? Scalene.
No, I'm not seeing the right angle, so.
Again, turning one problem into 3 distance problems. Classic Lindsay.
So how many rows you got on homework?
Huh?
How many rows do you have on homework?
I think 2. Okay. Write the equation of a perpendicular bisector of the line segment joining A and B. Okay? So there's a couple of things going on in there. First off, we've got the bisector part. Let's talk the bisector part first. Okay? So that is number 1, finding the midpoint, because that is where it is going to bisect. So if I'm going to find the midpoint, I would take the x values, add them together, and divide by 2. I would take the y values, add them together, and divide by 2. So the midpoint here is 5 plus negative 1 is 4. 4 divided by 2 is 2. 4 plus 6 is 10. Divided by 2 is 5. So the midpoint here is the point 2, comma 5. Do we all agree with that? Okay. Next, because it's asking me for an equation, I need to find the slope of line segment AB. So remember that the slope is the y's over the x's. Subtract the y's over subtract the x's. We talked about that one earlier. So that's going to be 4 minus 6 all over 5 minus negative 1. 4 minus 6 is negative 2. 5 minus negative 1 is 6. That reduces to negative 1/3. Okay. Then it was talking about being perpendicular. So we have to remember that perpendicular slopes are opposite reciprocals. We're just bringing all kinds of math into play here today. Huh? I love this section. Okay? So what is the opposite reciprocal to negative 1/3? So my slope is going to be 3. Now, I have a slope, or I have the slope of my green dashed line, which is what I want. I have a point that my green dashed line goes through. It goes through this point right here, which is 2, 5. So now I can use the point slope form. The point slope form, remember, tells me y minus y sub 1 equals m times x minus x sub 1. Yeah. So that's going to be y minus 5 equals 3 times the quantity x minus 2. Because my blue point is 2, 5. My slope is 3. And then to make that look nice and pretty, we're going to say y minus 5 equals 3x minus 6. So in the end, we'll say y equals 3x minus 1. Looking back at my picture, it goes through, has a y-intercept right there of negative 1, and it's got a slope of 3. 1, 2, 3, and over 1. Yep. Huh? Good times. Last style of question is, given the distance, find possible values of x between those two. Okay? Now, I'm going to graphically show you this problem, but you don't need to have a graph to do this problem. Okay? So just pay attention here at first. Okay? So the point 4, 6 is right there. Okay? There is 4, 6. Now, I don't know where that second point is. I know that it is somewhere on that green line. because it's got a y value of 3. And all those points on that green line have a y value of 3. Okay? So, if I were to draw out a line segment, that distance right there would have to be the square root of 18. Okay? Right? Is that the only spot that could be? Why not?
I'm not sure that that's the exact point that it's.
What about if I went over here? Same distance. Locked it in. Right? So how many answers am I going to look for in this one? I'm going to look for 2 answers in this one. Okay? So, how do we set it up? Well, we start with our distance formula. And then we fill in what we know. I know that the distance is the square root of 18. I know that my first x, or x sub 1, is what I'm looking for. It's x. I know that my second one is 4. I know that my first y is 6 or 3. It's 3. Yep. Because I started with x over here, I got to have 3 over there. Which means my second one is 6. Now, how are we going to solve this one? Let's use some math. Let's think math. Even before I can get the x alone. Even before I can do anything, what should I do? Think math. You've got a radical equals a radical. How can I cancel the radicals? Square both sides, right? Okay. I cancel out the radicals by squaring both sides. So that gives me 18 equals the quantity x minus 4 squared plus what? What's 3 minus 6? Negative 3 squared. 9. Now what? Subtract 9 from both sides. That's going to give me 9 equals x minus 4 quantity squared. Square root both sides. Right side, when I square root it. Right side is just x minus 4. Left side. Thank you. Why is it plus or minus? Because we're solving and we took a square root. So this one over here is plus or minus 3. Now what? Solve for x by So we get 4 plus or minus 3 equals x. So x can be what? No. 7 or 1. Okay. 4 plus 3 is 7. 4 minus 3 is 1. So my two answers here are 7 and 1. What that means is, if I were to go back up here to my picture, if I put my dot there, and 2, 3, 4, 5, 6, 7, I put my dot there, these distances, that distance right there, and this distance right here, are both equal to the square root of 18. If I lock those in. Okay? Just wait, Lisa. Wait for it. You go, girl. Okay? She wants you to take a picture of it and put it in the group chat.
I was gonna do that, but then she disrupted me.
Here, just wait.
Okay. Perfect.
Okay? Alright? So do Wednesday.